Hello and welcome to 2-5 Literal Equations and Formulas. Our SWABAT for today is to rewrite and use literal equation. First question, what is a literal equation? Well, that's an equation that involves two or more variables. So for our first example, we're going to solve each equation for y, then find the value of y for each value of x. So when it says to solve the equation for y, that tells me I need to get y by itself. Isolate it. So when I look at this equation, I first ask myself, okay, well, what's stopping the y from being alone? Two things, the 4 and the 8. So the two variable thing kind of confuses people. So I just cancel this and pretend like it's not there for a moment. And I say, okay, I'm ignoring this as well because no one cares at this point. I want to get y by itself. Well, if this was just a regular equation, I would subtract 8 first, and that's what I'm going to do now. Subtract 8, subtract 8. These are not like terms, so I'm going to write it as negative 5x minus 8. That's all I can do. Equals 4y. Now, if this 5x wasn't there just to try to irritate me and confuse me, I would divide 4 on both sides. The only difference now is when I divide by 4, I'm going to divide every single term by 4. I know some people just do the long fraction, but what I have found is that that kind of messes people up because they might forget to do it to one term. But if it works for you, go ahead. But this is me simplifying. This is negative 5 over 4x minus 8 divided by 4 is 2. So improper fractions, they're still fine, but you do need to reduce as much as you can, equals y. And if that bothers you, you can write it as y equals negative 5 over 4x minus 2. That's part 1. That's the first thing that they asked me for. It's kind of done. The next thing I'm going to do is find the value of y for each value of x. Well, here are the different values of x. I'm going to plug in for each of those. So the first one, when x equals negative 1, thought I was going to change colors there. When x equals negative 1, y is equal to negative 5 over 4x, but instead of x, I'm going to write negative 1 minus 2. Negative 5 over 4 times negative 1 is positive 5 over 4 minus 2. I'm going to write that as a fraction. My common denominator here would be 4. So 5 stays there, and for this one I'm going to times 4 and times 4. 2 times 4 gives me negative 8. And so then I have, oh, just kidding, this was already negative. I don't need an extra negative here. I have it with the minus sign. Horrible eraser. That. It's good to be prepared. Have a spare. So this is going to equal, what's 5 minus 8? Negative 3 over 4. That's the first value. Then you're going to do the same thing again, except for now for 0. It's the end of this equation. So y is equal to negative 5 over 4 times 0 minus 2. I like this problem a lot more. This times this is 0, so 0 minus 2. So y equals negative 2. And then for the last one, so let's kind of separate this out because I'm getting a little bit messy. Excuse me. Y is equal to negative 5 over 4 times 1 minus 2. So negative 5 over 4 times 1 is just negative 5 over 4 minus 2 over 1. And then I'm going to get my common denominator again, which is still 4. This already has it, so it's just negative 5. This I'm going to multiply by 4 again. Negative 2 times 4 is going to be 8. And I have negative 5 minus 8. That gives me negative 13 over 4. Remembering that you're going to keep the denominator the same. Okay, so my three values were negative 3 over 4, negative 2, and negative 13 over 4, just to keep it a little bit neater. Okay, same thing for letter B. We want to isolate or get y by itself. So again, you're going to look at it and see, okay, well, what's stopping it from being alone? The 4x and the 6. I usually multiply and divide last, so I'm going to move this 4x. Well, how? It's a positive 4x right now. So in order to move it to the other side, I'm going to subtract 4x and subtract 4x. these cancel out, and I have negative 6y is equal to, not like terms, so it's kind of easier. You just write them side by side. Negative 2x minus 2. Negative 4x minus 2, excuse me. Then, to get rid of that, I'm going to divide every single term by negative 6. This makes sure that I don't miss anything, basically. That's my whole reasoning for doing it. So these cancel out, and I have y is equal to negative over a negative cancel. And then I could reduce this. Do I want to? I do want to. I'm going to divide by 2 and divide by 2. So I have 2 over 3x minus, divided by a negative, equals plus. And then 2 over 6, I can divide by 2 and divide by 2 to reduce it to get 1/3. This is making me a little bit happier than the last one because at least they're common denominators. Like, yeah, I still need to deal with the fraction, but at least I already have the common denominators. Okay, let's try to plug in some values. The first one is x equals negative 2. When x equals negative 2, y is equal to 2 over 3 times negative 2, substituting the x for negative 2, plus 1 over 3. So then I can put this over 1 and multiply straight across and have negative 4 over 3 plus 1 over 3. The common denominator is 3. Negative 4 plus 1 is negative 3, which equals negative 1. So the first value I get is negative 1. And then if I plug in 0, I get y is equal to 2 over 3 times 0 plus 1 over 3. Well, this is just 0. So 0 plus 1 over 3 is equal to 1/3. Okay, do me a favor, please. Go ahead and press pause and then plug in x equals 2 into this equation and see if you get what I get. Press pause. Okay, did you press pause? If you did, I'm very proud of you. Let's check and see. I got 5/3. If you did not get 5/3 for the last number, go ahead and press pause. Check my work with your work and make sure that we're okay. Okay, next thing we're going to do is to solve each equation for x now. This time we are trying to isolate the x. We want to get x by itself. So again, same thing I was looking at when I was thinking about the y. What is stopping that y from being, I'm sorry, just kidding. What's stopping that x this time from being alone? So if I'm trying to solve for this, kind of just draw my attention because I have a lot of letters here. This is what I'm trying to isolate. So if these were numbers, this would be like 2 plus 2x. That's kind of like what this f is like. So what would I do first? Well, I would subtract 2 first, but I don't have a 2. I have an f. You don't have an f. I have an f. So I have d minus f. These are not like terms. That's fine for me. I'm just not going to combine them. Equals fx. Now, if this was just 2x instead, and I wanted to get rid of that 2, what would I do? I would divide by 2 on both sides. I don't have a 2. I have an f again. So I'm going to divide by f, divide by f. I know it's a fancy f, and divide by f. So what am I looking at? I have d over f, can't do anything with that, minus f divided by f. My f's cancel, delightful for me, equals 1. And then these f's cancel, and I have x. And if it bothers you, you can write x equals d over f minus 1. And there you go. So again, what we're doing here is you're questioning yourself, okay, well, what am I trying to get by itself? And what's stopping it from being alone? Maybe it's an introvert like me, and I just need some time by myself. So for the next one, I have x plus n divided by p equals n. So if I had x plus 2 divided by 3 equals whatever, what would I do first? I would get rid of that 3. How? Well, it's dividing. Just like this p is dividing. So to get rid of it, I'm going to multiply by p, and I'm going to multiply by p. So I have pm, not am, is equal to x plus n. And then my reminder, I'm still trying to get this x by itself. How? Well, I got to get rid of that plus n because that is stopping me. I'm going to subtract n, and I'm going to subtract n. Not like terms. Not like terms, not a problem. pm minus n, I just write them side by side again, equals x. And if you are a little bit like me, you're going to rewrite this because we do that. And there you go. Alright, we have one more example. If you can change to the next page. These directions go down here. Make that diagram for me. My bad. For these, we are again trying to get the x by itself. This x and this x. Looks a little bit risky. It is not. Think about this. When you have something like 3x minus 1x, what are we doing? What's the math behind that? Well, we're doing 3 minus 1, and we're keeping the x. That's how we would get that 2x. For us, what are we doing here? Same thing. Oh, you can't see me. Just kidding. When I was saying the 3x minus the 1x, we're doing 3 minus 1 in parentheses, and then we're timesing the x. That's how we get the 2x. My bad. So for us, we would subtract f minus g, that quantity, and we would keep the variable x. That all is equal to h. I have a quantity. That's fine. It's not going to stress me out. I need to get the x by itself still. That's my goal. What is this quantity doing to the x? Is it adding, subtracting, multiplying, or dividing? It is multiplying. So the opposite of multiplying by the quantity f minus g is to divide by the quantity f minus g. And whatever I do to one side, I'm also going to do it to the other. Well, this has been a delight. They cancel. So what is left? X is equal to h over f minus g. This one is probably, I've seen this in Algebra 2 honors. They freak out a little bit, but I'm just now showing you how to do it, and you survived it quite well. Okay, what's my next set? Well, my directions are way up there, but I'm still going to read it. Solve each problem round to the nearest tenth if necessary. And then it tells us to use 3.14 for pi. Okay, so for letter A, I have the width. What is the width? So W. Of a rectangle. So rectangle makes me think rectangle, obviously. With a length L of 14 centimeters and an area A of 161 centimeters squared. This area, kind of important, area of what? A rectangle. So I know that the area of a rectangle is equal to length times width. If you learn it as base times height, you're fine. No one cares. So I'm going to plug in what I know. I know that the area is 161, and I know the length is 14, and I know the W is question mark, the width, W. And then to solve, I'm going to divide by 14, and find that my width is 161 divided by 14, which is 11.5. 11.5 what? Centimeters. Don't forget your units on that one. Okay, your last one. This is where the radius part was talking about, use the pi. So what is the radius of a circle with a circumference of 13 feet? Well, what do you need to do this problem? You need the formula for the circumference of a circle. And that formula is C circumference equals 2 pi r. So for us, what is the radius, what is the r, of a circle with a circumference of 13 feet? So the C equals 13 feet. I like to decode as I'm reading my problems. So their circumference is 13 equals 2. They told me in the very beginning to use 3.14 for pi. So that's what we're going to do. 3.14 times the r. So 13, if I could simplify just a little bit, if I multiply 2 times 3.14, I'm going to get a number that is, I feel like I should do this in my head, 6.28. I'm not sure. 3.14 times 2. Yeah, I'm right. Times r, and then I'm going to divide both sides by 6.2r. Divide by 6.28, excuse me, not r. So 13 divided by 6.28 gives me 2.0777777. So this is what it looks like on a calculator. Yes, I was cheating and not doing this in my head. So that's going to round as 2.07. 2.07 what? Feet. Don't forget your units. It's kind of important. I take off a point for that. Go ahead, review your notes, and then write down anything that you thought was important or anything that you need to remember. Thank you very much.